Welcome to The Explainer. Today, we are diving deep into one of the most powerful, most mysterious, and frankly coolest objects in the entire universe, the black hole. We're going to go on a journey from a simple idea to the absolutely mind-bending reality at the very edge of space and time itself.
So here's our game plan for this cosmic trip. We'll kick things off with what a black hole even is, why we call it a prison for light. Then, we're going to dissect its bizarre anatomy. After that, we'll see how they're born in a blaze of glory, learn how astronomers play detective to hunt them down, and finally, we'll get into the really deep stuff, the riddles that are still keeping physicists up at night.
All right, let's start at square one. What exactly is a black hole? If you strip away all the science fiction, what does physics actually tell us?
Okay, so the basic idea is kind of simple, but it's also completely mind-blowing. Just imagine taking a ton of stuff, a lot of stuff, and squishing it into a space so tiny that its gravity becomes all-powerful. It gets so strong that to get away from it, you'd have to go faster than the speed of light. And, well, since nothing in the universe can go faster than light, nothing gets out. Period.
And you know what's wild? This idea has been kicking around for a surprisingly long time. Way back in the 1700s, guys like Jean Michel and Pierre-Simon Laplace were thinking about dark stars using Newton's ideas, but it was Albert Einstein who really changed the game with general relativity. He showed us that it wasn't just about being big, it was about being incredibly dense. So dense that you don't just pull on things, you literally bend and break the fabric of space-time itself.
So if they're completely invisible, how in the world can we talk about their structure? Let's take a tour of one of these cosmic giants. Fair warning, this is the place where all of our normal, everyday intuition just completely falls apart. First up, the most famous feature, the event horizon. Now, it's really important to get this, it's not a surface. You couldn't touch it. Think of it more like a one-way door in space. On one side of the door, you can still escape, but the second you cross it, every single path, no matter which way you turn, leads to the exact same place, the center. There's no turning back. And at that center, you find the singularity. This is the heart of the beast. It's a point with zero volume and, get this, infinite density. The entire mass of a star, or maybe even billions of stars, crushed into a space smaller than a single atom. This is the point where our rulebook for the universe, all our laws of physics just gets thrown out the window.
So you can imagine this whole journey inward, right? It's pretty wild. Even before you get close, you hit the accretion disk, this insane, swirling whirlpool of gas and dust heated to millions of degrees, glowing brighter than an entire galaxy. Then you'd pass through the photon sphere, a really weird place where light itself is trapped in orbit, before finally, silently, crossing that invisible line, the event horizon.
Okay, these things are incredible, but where do these cosmic monsters even come from? Well, their birth story is all about violence, fire, and the death of a star. First off, you gotta know that not all black holes are created equal. They come in all sorts of sizes. You've got your stellar ones, which are, a few times bigger than our sun, but then you have the supermassive and ultramassive ones, the absolute titans that are hiding in the center of basically every galaxy, including our own, with the mass of millions or even billions of suns.
So, the most common type, a stellar black hole, is born from a death. You take a really big star, at least 8 times bigger than our sun. For its whole life, it's in this epic tug of war, nuclear fusion pushing out, gravity pulling in. But eventually, the star runs out of fuel. The outward push just stops, and gravity wins. Instantly, the core collapses in on itself with unbelievable force, creating something so dense our brains can barely handle it.
All right, I know what you might be thinking. This sounds like something straight out of science fiction. How do we know, for sure, that these things are actually out there? For a long time, they were just an idea on a chalkboard. I mean, that's the big problem, isn't it? By definition, a black hole gives off no light. It's just a patch of perfect black against the black of space. You can't just point a telescope and snap a picture of one. So, what do you do? Well, you do it like a detective. You can't see the culprit, so you look for the evidence they left behind. Astronomers track stars that are being swung around at insane speeds by something they can't see. They use special telescopes to spot the super bright X-rays getting blasted out by that hot gas spiraling in. And as of 2015, we can even hear the literal ripples in space-time, gravitational waves, that are created when 2 black holes smash into each other.
And a perfect example of this is right in our own backyard, at the center of the Milky Way. For years, astronomers watched these stars zipping around like crazy. The only thing that could explain their movements was an invisible object with the mass of 4.3 million suns, all crammed into a tiny, dark spot. So for decades, this was it. All this super strong, indirect evidence. The object called Sagittarius A star had to be a supermassive black hole. The case was basically closed, but we still hadn't seen the suspect.
But then, in 2019, science did something that was supposed to be impossible.
By linking up radio telescopes from all over the world, a project called the Event Horizon Telescope basically turned our entire planet into one giant telescope lens. And with it, they managed to take a picture. Not of the black hole itself, you can't, but of its shadow cast against all that glowing hot gas around it. This was the monster in the M87 galaxy. It was the first time we ever saw the unseeable.
So we finally saw one. Case closed, right? Nope, not even close. If anything, seeing it just made the remaining mysteries even more fascinating. Now we're heading to the absolute edge of what we know, to the cosmic riddles that black holes still present. And this leads us to one of the biggest throwdowns in all of modern physics. It's called the information paradox. See, we have two sets of rules for the universe. Rule #1 is general relativity, and it says that anything that falls into a black hole is gone forever, wiped from existence. But rule #2 is quantum mechanics, and it has a golden rule. Information can never be destroyed. So what happens at the event horizon? Our two best theories flat out contradict each other. One of them has to be wrong, or at least incomplete.
And that leaves us with this incredible, almost personal question. Is the universe's memory of something, of you, truly gone for good? It's a huge reminder that these weird, dark objects aren't just an endpoint. They're a laboratory for testing the absolute limits of reality. And they show us that our journey to understand the cosmos, well, it's really just getting started.